The adapter pattern is a structural pattern which eases the design by identifying a simple way to realize relationships between classes. In this video, we will take a look at the characteristics of the adapter pattern, and then, using a demonstration, we will clarify the concepts. The adapter pattern converts an interface into another interface which the client expects. So it allows classes to work with each other, which would not normally be possible due to incompatible interfaces. So one of the big advantages of this pattern is to reuse existing code whose methods may not conform to the method names the client is expecting. One often cited example of this pattern is the one of power adapter. So the US power socket is not the same as the Indian power socket. So when traveling to India, the US laptop power plug would not fit in the Indian socket. An adapter here comes handy, which at one end fits in the Indian socket and at the other end provides the familiar interface or the socket structure the US power plug expects. Again, you can have many adapters, so another adapter for the European wall socket, etc. Here is the UML diagram for this pattern. So our client is calling the required method provided in the target interface. Here is our legacy class which has a method called other method which the client cannot call. So we create an adapter which implements the target interface and so implements the required method, and inside it calls the legacy class .other method. Let us take a look at a code example. Here I have Spring Tool Suite running, which is a flavor of Eclipse. Here I have a simple Java project where I have already created some classes to save us some typing time. Here we have a US socket interface to which the US sockets comply. It just has one method, powerup. And here is a concrete US socket class which implements this interface. Inside the powerup implementation, it just says plugged in and running from US power source. Similarly, we have an interface for Indian sockets called Indian socket interface. It has a method provide electricity. Here is a concrete implementation of the Indian socket interface where again in the method we are simply returning plugged in and running from Indian power source. So that is good. Each country has its own socket interface with the API or method names which the electrical plugs for the devices of that country will call. Now here is our client class, the US power plug, which through its constructor takes in the US socket interface and assigns it to the local variable US socket interface of type US socket interface. Then inside its plug and run method, it calls the US socket interface .powerup method. So our US power plug client expects that the US socket interface will be passed to it and it will invoke the powerup method of it to plug in and run. So let's first create a test class. So right click on the project and choose new and then class. Let's call it tester. Let's check public static void main. Click finish. Alright, let's first create an instance of US socket by calling US socket interface US socket is equal to new US socket. Next, let us create our client US power plug as new US power plug, providing it with the US socket with which it knows how to work with using its plug and run method. Let's run it by right clicking and choosing run as Java application. We see it says plugged in and running from US power source. Next, let us create the Indian socket which conforms to the Indian socket interface. If we try to construct our US power plug passing in the Indian socket, it will give an error as it does not understand the interface. The interface does not provide it the powerup method which it is familiar with and calls. Rather, the Indian interface has a different method called provide electricity. This is where an adapter comes handy. So let's right click on the default package, choose new and then class. Let us call it Indian power adapter. Our Indian power adapter will implement the US socket interface. Click finish. The adapter will have a local Indian socket instance of type Indian socket interface. This instance is assigned a value using the constructor. Then, inside the power-up method of the US socket interface, it calls the provide electricity method of the Indian socket. So the adapter translates the method requested by the client to the appropriate method of the implementing class. Now, let us go back to our tester class. Let us now wrap our Indian socket with the Indian power adapter. This will return back a class which implements the US socket interface which the US power plug understands and calls. Let us call US power plug.plug and run, which will call the power up method of the US socket interface, which will then translate the request to Indian socket.provide electricity. Let us run this class by right clicking and choosing Run as Java application. And we see that indeed our US power plug now can work with the Indian power source using the Indian power adapter. We can similarly create multiple adapters, say one for Europe, one for other Asian countries, etc. In this video, we discuss the characteristics of the adapter pattern, which allows classes to work together, which otherwise would not be able to do so due to incompatible interfaces. We then saw the concept in action using a demo. Thanks for watching.